Okay, so this says R is cosine 2 theta. R equals cosine theta 0 pi. And I want to find the points of intersection of these two things. So I think we did this one, right? So cosine theta just straight up looks like a circle. So you do need to draw them. So that's R equals cosine. R equals cosine of 2 theta. I don't remember what that looks like right off the top of my head. What does that look like? Is that the propeller thing?
Yeah, I think so.
So I think, can't remember exact. So I know that it looks like a propeller. Let's see. So does it go? No, no, at least it looks sort of roughly like this. Nice. And I know it starts here. I don't think it goes up quite as high. So if I were to look at the intersection points, it looks like there's one there, there's one there, there's one there, and there's one there. So trying to figure out where those points are. So the first step you normally do on this is you take cosine of 2 theta, you set them equal to each other. And this will give some of them, but others you may have to go back and look at the graph in another way. So they do hit at the origin. So I know for sure that the origin, so here's my intersection points, are at the origin. And I may get that out of here anyway. I have a point here, and if I try to figure out where cosine and cosine 2 theta are equal to each other, well, I mean, one point that's clear is that theta equals 0 works. If I was to plug in 0 here and 0 here, I'd get cosine 0 on both sides. So that point right there is when R and theta are equal to 1 and 0. So that's that point right there. So I can get that straight out from just this here. Now, how do I get the rest out of this equation right here? Well, is that what's the problem, is trying to figure out how to solve this part out here?
Yeah.
Okay. Just a second. Okay, let's think about it. So cosine of 2 theta, maybe there's some nice identity on that one. Where's my trig identities? Or maybe not. Cosine of 2 theta is equal to, there's a couple of identities here. Cosine of 2 theta is equal to 2 cosine squared of theta minus 1. I think that's going to be the one that's going to work. Yeah. So you're like, really? That doesn't seem to have helped at all. But if I write it like this, cosine of 2 theta, or 2 cosine squared minus cosine squared minus 1 equals 0, then that's, I think you can factor it. we write this as 2 cosine theta and cosine theta for that one. And I know that this has to be 1 and this has to be 1. And I just got to put the minus in the right place. It looks like the minus has to go here. So when in doubt, go find some trig identity. And if you put that in and do just, you can use quadratic equation as well, but if you use a basic factorization, then we'll get this set up here. So what would that mean? That would mean that the cosine of theta would have to be equal to 1, and that occurs when theta is 0. I'm only interested in the answers between 0 and pi anyway. But it's true it's also the case at 2 pi, but that's sort of out of our range. Any multiple of 2 pi is going to work there. Here, that means that 2 cosine theta plus 1 is going to have to be equal to 0. So, you know, two things multiplied together being 0 means one of them has to be 0. So that means that the cosine of theta, I bring the 1 over and divide by 2, has to be equal to -1/2. So what angle will give that? So cosine is negative in the second and third quadrants. And since I'm only looking in 0 to pi, that's only in the first and second quadrants. So in the second quadrant, that's when theta is 2 pi over 3. So at 120 degrees, cosine is equal to -1/2. So there is my, there's my value. And what would be the R value on that one? Well, the nice thing is I'm doing intersection points, so all I got to do is just take this and plug it back into either one of these two equations to figure out what R is. So if I put 120 degrees in there, well, look, it's the same. So this ends up being -1/2. And so that right there is my other intersection point. And again, that looks weird because wait, R is negative, but the point is you rotate 120 degrees and then you take a half step back. So I rotate 120 and I take a half step back, I'll get right there. And then this one is that right there. And this point, yeah, I don't want to draw a complete arrow all the way over here. So I get these 2 points from looking at setting them equal to each other. If I was to look at my picture, figure out where they intersect, they also intersect at the origin. And that's not gotten from setting them equal to each other, because they hit the origin at different places. So in order to get to the origin, I need this angle to be pi over 2 so that the radius is 0 and I'll hit the origin. This one is going to occur when the radius is, when this angle is pi over 4. Because pi over 4 times 2 is pi over 2. The cosine is 0. So if I were to draw these simultaneously and watch them move, they wouldn't hit the origin at the same point, but they would hit the origin eventually. And then I think maybe this one here probably is just the mirror symmetry of this one down below. So that point right there would be theta is pi over 3, and the radius is 1/2. So that's another one. It's not going to come out of setting them equal to each other because they both reach that point at different points. But when you draw the complete graph, they do hit on all 4 of those. So you not only have to look at the picture, or not only have to do this set equal to each other, but you need to look at the picture. That might be a longer answer than what you wanted, but that's the full answer.
Thank you, sir.
Sure.
Sir?
Yep.
I accidentally submitted the homework without doing number 50 because I don't know how I just skipped over it.
Well, just
And
I don't know.
it's because I wrote 50 on a bottom line, and I just didn't see it, so I didn't do 50. Could I still submit it?
Sure. Yeah, that's fine.
How would I do that?
Try on Canvas.
Okay.
Yeah. Some of that stuff's a mystery sometimes. I don't think it'll override it. It may just additionally add it on, but if it overrides it, then you probably just need to resubmit the whole deal.
Oh yeah, I can do that. Thank you.
So just be careful. All right, what else? What are you doing to stay awake out there, Aiden? Got coffee going or tea or just
Oh,
living
no,
life?
so I actually don't. I'm just going right at it. It's not working too well. So
I'm sorry.
yeah, that's okay. I'm grinding through it. So
Okay.
done early with. So
Yeah. Okay. The I did. If you guys haven't looked, all these videos are on YouTube. If you go on Canvas, you know there's only 2 modules, and one has all the book and the syllabus and stuff in it. The other one has all of these notes from the class in the PDF, and there's one file that's one page you can click on, and you'll get to the YouTube page. And you know, it's a lot there. The lectures are long, but if you want, you know, you can sort of scroll through quickly to see any pieces you might have missed. I think I might have missed one little part earlier, but I'm trying to be careful on that. So you can do catch up if something you missed or drift off. I can understand that. It's hard to be in these things for this long. All right. Any other questions? Or we can just hang out and you can work, and things pop up. Just ping me here.